Alright, so for this demonstration, we're going to take a look at the effect of temperature on reaction rate. So I know it's kind of difficult to see in the video, but I'm going to show you guys the same reaction twice. I'm going to run one reaction at a really hot temperature, which you can see here. I have a beaker on a hot plate. This reaction is currently at about 85 degrees Celsius. And then we're going to run the exact same reaction, but this time we're going to cool it down. So I've got this reaction, these test tubes cooled off at about 5 degrees Celsius with some ice there. It's kind of a cool reaction. We're going to be mixing sodium bisulfite with potassium iodate. When you mix those two together with just a spray of starch, it kind of gives you this really cool, like, dark blue, purpley color at the end of the reaction. So that's how we'll know the reaction is over. So I'm going to go ahead and mix test tube A and B from both the hot and the cold solutions in the beakers in front. And I'll do my best to start the timer right as soon as I mix them, but we should be able to see a clear difference. The warmer reaction should have a much faster reaction rate, and the cooler one should have a much slower reaction rate. So let's see if that is the case. So here's the cold reaction. Start my timer. And here's the hot reaction. Start my timer. And we'll know when the reaction is done because it'll turn that dark purple kind of color. There we go. Already I see the hot one seems to be turning there. Awesome. Okay, I'm going to go ahead and hit stop here. So this time was about, I don't know, 32 seconds it looks like. And my cold one still has not finished reacting. Which makes sense, because if you cool off a reaction, the reaction will progress much slower. So again, this one was colder. I cooled it off with some ice. So we should see a much longer reaction. Already my timer looks like it's at minute 15 seconds still going, compared to the 32 seconds for the hot reaction. I'll see if I can move this up top here, because it is kind of fun to watch it change. There we go. We look like we're getting something to change here. Much slower. So I'm starting to see that purple color at about 2 minutes and 10 seconds in. Clearly a much slower reaction at a cooler temperature. And there we go, about there. I'll go ahead and hit stop on my timer here. So my reaction for the cold one ended with about 2 minutes and 44 seconds, and the hot reaction was over very quickly at only 32 seconds. So again, this just illustrates that if you warm up a reaction, the rate will go much faster. If you cool it off, the rate will be much slower. This has been a Rodriguez original production. I hope you enjoyed. Go back and study your notes. Good luck.